So first part, the warm up. For each graph, you're supposed to tell me, is the solid or the dashed line better for the line of fit? So table 3, start us off. Do you think the solid line or the dashed line? And why the solid? Okay, so because it is in the middle of the data. We learned yesterday that because sometimes you have to draw the line of fit yourself, and that should be easy points on the test. Because you just have to draw it through the middle of the data where all the points seem to be clustered around it. Do all the points seem to be clustered around the dashed line? No. So that's why the solid line is better. Is it important that the line touches all the points? No. Is it important that it touches any of the points? No, it just has to go through the middle of the data where the points seem to be clustered around it. So then table 4, for number 2, solid or dashed? Solid. Okay, yes, the solid line is better. The dashed one is above pretty much all the points. The solid line is better. Even though both lines are close to all the data, the solid line is through the middle. Now table 1, number 3, solid or dashed? Okay, I agree. Dashed, dotted, same difference. But yes, the dashed line is going through the middle of your data, whereas the solid one is not. The points should be clustered around it. And table 2, number 4, solid or dashed? Okay, I agree. The solid one is under the majority of the points, whereas the dashed one's more in the middle. So that's how you know, that's easy to tell. Now, today's goal is to, I'll even pull it up because I haven't shown you the slides much this week. The slides always have everything you need, what the goal of the lesson was, and how you know you're successful. So if you can describe the rate of change and y-intercept for a linear model based on whatever situation it's about, then you've met the goal. So it could be about how much someone gets paid and how much money they make. So like how much they worked and how much money they earn. If you can have an equation that represents that, you need to tell me that the slope, also known as rate of change, what it means for that specific situation. Like for each additional hour that they work, they make $20 more. Something like that. Slope is always what is changing. Your y-intercept, when it comes to like a word problem, is your starting amount, or if it's like not a situation that like we normally have a starting amount, it's whenever x is 0, that's your y-intercept. So if x is like hours worked, then that means at 0 hours worked, they still have, I don't know, $10. I don't know. Maybe they just get $10 for showing up. Something along those lines is what your y-intercept is representing. Lastly, using technology to find the line of best fit. Yesterday, I showed you how to do that by hand, and sometimes you have no choice. Sometimes you have to do it by hand because they don't give you a good table to go off of. But if they do, then you might want to use technology to save you some time and to find the most accurate answer. I'm recording right now. It'll be linked in the slides. If you need like a reminder of how to do this, like in Desmos, that's what I linked also in the slides. All right, we don't care about the ad. All right, but after that, it's like a really short video how to use Desmos. Anyway, the puzzle piece is in Schoology. I forgot to put a picture of it in there, but it's there, lesson 5. It's literally 3 questions. All the practices this week, even though you've had like 5 practices this week, have each been 5 questions or less. And I know like there's not a lot of options in them, Like, obviously, if there's two options and it's not true, then it must be false. But you also need to know why. If you're not understanding that, make sure that you're asking. You do have a quiz on Monday over all the unit 3 stuff we've covered so far. And I told you, unit 3 was really short. There's 9 lessons total. So next week we don't have a unit test. We just have that quiz on Monday. So then the week after is our unit test. So do not let yourself fall behind. I know you have till the end of the unit to turn in late work with no penalty, but you should do that earlier than the end of the unit. So then on to the first activity. And I will say, I wish that they labeled the variables differently, but that's how they gave it to us. Usually when you have a situation, your X is something that's independent and your Y is something that's dependent. So the two variables are the weight of ice cream sold at a small store in pounds, that's gonna be X. And the average temperature outside in degrees Celsius, that's gonna be Y. Personally, I wish that they reverse them, because I don't think the temperature outside depends on how much ice cream you sell. I think it's the other way around. But anyway, that's how they labeled it, so we'll just go with what they said. For this data, you're gonna make a scatter plot by hand at first, at least. They didn't provide you a scatter plot, but I provided you one. Now, you have to decide what you want the tick marks to go up by. So if for the X's, my values go from the smallest is 17, my highest is about 22. Make sure that your X-axis covers all of the numbers. For the Y-axis, my smallest is 3.5 and my biggest is 7.5. Maybe consider counting by 0.5s if you have enough room. But plot your data on a scatter plot. I'll show you how to do that in Desmos shortly. So once you've plotted it, log into your computer and pull up Desmos. And I'll freeze to start plotting as well. All right, so here's how I made mine. Granted, yours could look different depending on how you labeled your axes. On the X-axis, each tick mark is 2. I didn't label every single tick mark, but it goes like 2, 4, 6, 8, 10, 12, but you could have done it. On my Y-axis, I did it by 0.5s. And yeah. Anyway, most of my data is like in this format. So depending on what you counted by, it should still look something similar. It just might be like more spread out, depending on what you do. Now, graphing by hand, setting data points by hand, and we seem to really only have like 3, 6, 7, 8. This was only 8 data points. That was still kind of time consuming to do by hand. And then the next step would be to sketch a line that fits the data well. So something like this is what I'm thinking. But again, that's a bit more time consuming. If you are taking your test and you need to compute a line of best fit, so we're on to number 2 now, I highly recommend using technology. You won't be able to use technology in all situations, which is why we still showed you how to do it by hand yesterday. So I'm gonna switch for a second. Like if we look at the scatter plot in this warm up, like this one, I don't have a table of values. I could try using technology, but then I'd have to estimate every single dot. And there's a lot of them and I could mess up. So like sometimes you just have to do it by hand. But if you have a table, highly recommend use Desmos. And I'll show you how to do that right now. So I suggest while I do this, you take notes or you do it yourself, like to build muscle memory.
It's easier for me to just tell you than to give you like a bunch of steps. All right, so you're gonna pull up Desmos graphing calculator. You can also do this in any handheld graphing calculator. There's just so many out there. And I know like at least you'll all have access to Desmos on your tests. Not your state test, but you can figure out how to plot a line of fit with whatever calculator you do on. But in Desmos, you will insert a table by pressing this plus sign where it says add item. Everyone see that? You click it and then hit table. And then your table of values, you're going to enter into Desmos. And with a normal graphing calculator, this process is similar. You need to find where you can enter a table of values and then do that. So you should be doing that too, or writing the steps, either one. But we're copying our table into Desmos as the first step. Try not to mismatch any coordinate pairs. And then what this does is it electronically creates your scatter plot. And again, they spaced out their numbers different than I did, so that's why it looks like this, but it's a similar pattern. To put a line of fit using technology, using Desmos, in a different cell, you're going to click and you're going to press these buttons. Your buttons you're going to press are going to be Y1, squiggly line, MX1 plus B, which then makes your linear model. It goes through the middle of your data where all of it's clustered around. Because we could have some errors when we make it ourselves, like there could be some variation. But the computer does it completely right all the time, unless you put it in. Note that when you put the Y1, you don't have to format it any special way. Like it'll automatically make it a subscript. The only like tricky part that everyone forgets is that it's like that squiggly line instead of an equals. So the squiggly line for me is like my top left of my keyboard, and I like hit shift and I then press that button. And then you just type in X1 plus B and it'll automatically format that one. Questions on that? Now I know someone on Monday is going to try doing this and they're going to forget that it's a squiggly line and they're going to put in equals and then it's going to have like an error message. I cannot help you during a test with your calculator. Like you just would have to do it by hand. So that's why you have space in your notes. Maybe write this down. Put in Desmos. Press this, the little squiggly line, all that stuff. Questions on that? If you can use your notes on quizzes at least. By the test, you need to have that formula memorized. Now it gives us a lot of great information. Some of it we will use not today, the next week. Today, all we need is the line, the equation of the line. And it gives us the two things that we need for that. So what's my slope for this line? What letter is M? All right, I guess I give it away. What letter is for the slope? M, right? And it tells me M equals this. It says rounded to decimal places. So that would be about 0.78. X, and then what's my y-intercept? Okay, good. And it did say round to decimal places. So that we get from this without having to do the other algebra that I showed you yesterday. Questions on that?
So that is our linear model. This equation is. And now we can use that to answer other questions. All right, questions before I move on. Okay, so in number 4, you're gonna do that with your groups. We already kind of answered some of it already. But we have slope and y-intercept. What are they? And then what do they mean in the situation? So when you're talking about what they mean, you need to tell me something about the pounds of ice cream and something about the temperature outside. So that's the 2 variables. So like 0.78 what? Negative 9.44 what? What is that representing? And then number 5 says use the line of best fit, which that's our line of fit, what I highlighted in yellow, to predict the y value when x is 10. And then tell me if it's a good estimate or not. So do that. Number 4 and 5 is what I'm having you do. Make sure by the end of 4 minutes that you guys agree. You will find a reporter after that. 4 and 5. 4. These are slopes. Okay, great. Now, what does it mean in terms of the situation?
It's the change in temperature after each ice cream is consumed.
Okay, change in temperature is 0.78 degrees for every 1 pound of ice cream sold. So think of it rise over run if you're ever unsure. Slope is rise over run. What's on the y-axis? Like the y's were what in the situation? For the whole class now. So what was y in the situation?
The temperature is changing.
Okay, yeah, and so when slope is rise over run, that means that the 0.78 over 1 is technically what it is. Rise is y, so that means it's the change in temperature for every then whatever the x was. So x is your run, what's on the x-axis? Pound of ice cream specifically. So yeah, that's the change in temperature for every 1 pound of ice cream sold. Now, I wish that they reversed it because I feel like it makes more sense to say like, when the temperature increases, we sell more ice cream. I feel like that's more like what's actually going on. It's not like the more ice cream you sell, the like temperature changes outside, right? But that's how they set it up. So the temperature is increasing by 0.78 of a degree for every 1 pound of ice cream sold. Questions on that? That is correct. All right, now table 1. What is my y-intercept? So my v and y-intercept is b of my linear model. Remember my linear model that I highlighted in yellow? Negative 9.44, but yes, is my y-intercept. Now, table 1, what does that mean in terms of the situation? Negative 9.44 what? So is that my temperature or pounds of ice cream? tried. But no, because y-intercept, what's on our y-axis, or what is the y in the situation again? It did define it for you. Y's are the. Come on, guys, in the very first part. Well, I was asking table 1, but still, like, look up here, everyone. This description says, the weight of the ice cream sold at a small store in pounds X and the average temperature outside in degrees Celsius Y. So the temperature outside in degrees is what's on my y-axis. If my y-intercept is negative 9.44, that's still referring to temperature. Does that make sense? So it's negative 9.44 degrees when what happens? So when you want to try to tell me the rest of it? So we know that it's negative 9.44 degrees when what happens with the other variable being compared. All right, table 2, help out. What's the other variable that the temperature is being compared to? Okay, let's go back and reread it. There's only 2 things being compared at a time. So we'll let table 2 do it. What did you say, Naya? Okay, here it is. And I'll reread this again. This is not like the 3rd time I'm reading. The question is, what 2 things are being compared? We know Y is for temperature. So let's reread it again, because this is where you get the information. Like when you're taking your quiz on Monday, reread it to know what letter is what. But we have the weight of ice cream sold at a small store in pounds X and the average temperature outside in degrees Celsius Y are recorded in the table. We're trying to say what the y-intercept represents. We know that since y is referring to the temperature, we know that our y-intercept of negative 9.44 means that that's the temperature outside. But what's the other thing the temperature was being compared to? We're having the table 2 right now. To the pounds of ice cream sold. How many pounds of ice cream were sold at the y-intercept? So let's see, maybe on the graph it will be better. The one that has it where the y-intercept is actually showing. So let's look at the graph, everyone. So that's our y-intercept, right? X is for pounds of ice cream sold. How many pounds of ice cream were sold when it's about negative 9 degrees? None. So when 0 pounds are sold, is when it's that temperature outside. Make sense, everyone? Okay, so negative 9.44 degrees when 0 pounds of ice cream is sold. That's what the y-intercept is. The y-intercept is always when x is 0. So if you can tell me what x represents, then the y-intercept is when that variable is 0. Right, so if you're comparing like hours worth to how much money was made, our y-intercept would tell us when 0 hours are worth. Whatever x is would be 0 at the y-intercept. Questions on that? All right, that's a lot of questions on your text, quiz and managed text. Now the next part. Use the best fit line to predict the y value when x is 10. So the whole reason we even have a linear model is so that we could predict stuff that we didn't necessarily gather when we took our data. Okay, so the whole line is a prediction. So we're going to use that equation of the line, so feel free to copy it down, to predict the y value when x is 10. So what do I need to do with that 10? Fill it in for the x. So take your linear model. Y is still unknown, so we're gonna leave it as y, but they're saying when x is 10. So instead of x, you're putting in x. And that you can put into your calculator and solve. And get a value for what y are. All right, table 3, tell me that value when you have it. Okay, great. So when you have to plug in for x, it's pretty easy because the y is usually already isolated in your linear model. Find a calculator or use Desmos where you can just enter the whole right side in at once and not have to worry about order of operation. If you had to plug in for the y, then you're just solving for x, which we've done plenty of times, so we know how to do that. But yeah, that is telling me that when x is 10, so remember what is the x representing again? And what? So when we sell 10 pounds of ice cream, what temperature is it outside? Okay, good. Temperature outside. So if it's gonna be a pretty cold day, because that's a pretty low temperature, I can expect to sell still 10 pounds of ice cream. So maybe that's enough for them, maybe it's not, maybe they'd rather close for the day. But that's what the whole purpose of a linear model is. Once you have it, you use it to predict things, whether it's an input or an output. Questions on that? Okay, so, in your bins, you will find some data. And it'll be different from like the other tables, so make sure you find like a thin slip of paper with data on. You guys are now going to practice what we did in Desmos. So you're gonna do it for the data that you have. Maybe like take a picture of it, pass it around, maybe partner like together and like get the same computer to do it, I don't know. But you need that data, you're plotting it in Desmos and making a linear model for it. Once you have that linear model, you're writing it on this blank. Under number 5, right here. Your teacher will give you a different set of data to practice using technology. But your answer for your line of fit there when you have it. Okay. If you run into the issues, let me know.
So you just practiced how to do it with a different set of data than the example we did together. So again, it works if you have like a table where you could see all the coordinates, or it could work if you can just see all the coordinates really well. Otherwise, then you'd have to do it by hand and remember that process. But take note, like on each of your data tables in the top left corner, there's a letter, because you guys didn't all have the same data. You guys, each table probably had different data. So I'm going to show you what the equation should be, and you'll see if you're right. You should have written down your equation from Desmos. So if you had data set A or B, this is what it should have looked like, and then this is your slope and y-intercept respectively. And of course, depending on what you rounded to, it's probably different, but like, hopefully you know your rounding rules.
Wherever you want to round to, you underline it, look to the right. If that number is 0 through 4, then it stays. The number you underline. If it's 5 through 9, you go up 1.
All right, now I'm going to show you CD. So if you had data set C or D,
You have to look at the top left of your table to see what data set you have. Then that's what your equation should have been. Of course, if you rounded, it might be slightly different. Question? Okay, isn't that pretty close? So negative 0.32. Oh wait, hold on. Well, B, that's B. I'm showing you C and B. Oh, okay. Let me go back to a B instead. Isn't it negative 0.3 close to negative 0.4? It is. They'll all be pretty close. I'm betting you must have missed one, or maybe typed in it a little bit different for that to be some variation, but like that, it should be close to it. If it's not exactly this, it might have just been on this one. Or entered it twice, or I don't know, mismatched it. Anyway, so that was CD. Now, if you had E, here's yours. If you had E. So if you got it exactly right, you typed in all your data the right way and you typed in the line the right way. If it's slightly off, it still should be close, so it should still be helpful to use Desmos. You would still pick the answer that's closest. But you probably just missed a coordinate or something, I don't know. Questions on how to do this? All right, the rest of the time, and I know the bells are off a little bit, you have to go by the bell, not the time. The rest of the time, work on your puzzle pieces for the week. I know today's practice is only 3 questions, so you know, you probably knock that out, even in the little time you have. But really, everything from unit 3, you should be prioritizing. This is on Monday. But on Monday.